Hello world, Noah here. In this video, I'm going to show you kind of a funny application of reflection in Java. Just take a look at this code that I have right here. Take a moment to pause the video and guess what you think it'll print out. Then I will run the code, and after that I'll explain exactly what happens. Okay, so hopefully you have a guess at this point. I'm going to go ahead and hit the run button. We have just x is 0, y is 1, and z is 2, and we print each one out in a row. Nothing special there. But if I run this, you'll see that it says 0, 2, 2. The first one, x, makes sense, and z also makes sense, but y doesn't. Y should be 1, not 2. Now, I'm sure you've probably noticed that this code is all the way at line 55, which means that I'm hiding a bunch of stuff from you. And indeed, I do have all of this nice code up here that does something a little bit strange. But first, we need to understand exactly what is happening. We need to understand the difference between these three lines, between x, y, and z, because there is a difference between y and the other two that makes it susceptible to this trick that I did up here. And once we understand that trick, then we can take a look at how to actually write this code. So the first line, line 55, where we say int x equals 0, is very, very straightforward. We just have x, it's an integer, the primitive type integer, and the value is 0. And I go ahead and print it out. There's absolutely nothing special there at all. Now when we look at y, it's very similar, but instead of using the primitive type int, I'm using the wrapper class integer. So as we know, integer is a class that is basically a stand-in for int. So when you need a class type, like for generics, like an array list or a hash map, then you can use integer instead of int. Now, as to why this 1 works here, when I can say integer y equals 1, even though integer is an object type, this is a Java property called autoboxing. And what that means is that when I write 1 like this, Java will automatically basically call the constructor like this. So if I were to write, 2 here, then lines 58 and 61 would be the same, because when it sees 2, it automatically sticks it in here into the integer constructor and converts it to an integer. And so at this point, this is not an int, it's not the primitive type, but rather it is integer with a capital I. It is the wrapper class type. And here it's the same thing, but I directly call the constructor. I call the constructor myself instead of using autoboxing to have it automatically call the constructor. So it's pretty clear what the difference is between x and the other two. X is the x is the primitive type, so I'm not dealing with any object types at all. So x makes perfect sense. Now y and z are very similar, but they're a little bit different. When I use z here and I create a new integer, I'm manually calling the constructor, quite clearly, but here I'm not calling it automatically. And what Java does is when you first start up Java, or I guess it's really when you load the integer class, which is either loaded by Java automatically or by you when you reference it. But whenever the integer class is loaded, it contains inside of it a cache of integers. And so let's just take a look at that for 1 second. If I hold Command, or I think Control on Windows, and click on integer, I can actually see the source code for integer, and we're looking for integer cache, which is not there, but here. So within the integer class, which is defined by Java, there's a secret hidden class inside of it called integer cache. It contains 3 values, low, high, and then an array called cache, and it's wrapped inside of this static block. Static blocks are called, I believe, when the class is loaded by the class loader. So static, if you write the word static and then you put a block there, then whatever's inside of the block will be called when the class is loaded. So it'll basically be called automatically. And so what this does essentially is, you can ignore all of this code, but this is really the important part. It initializes a cache of integers, an array of integers, integer being the capital I, and then it basically goes through and instantiates new integers for each one of them. So essentially what that means is if low is negative 128 and high is 127 by default, that can be changed based on this property, but by default it's 127. Basically, for all numbers between negative 128 and positive 127, it will instantiate an integer for that and stick it inside of this cache array. Now, why would we want to do that? Well, these numbers, these smaller numbers, are pretty common. I mean, I suppose that if you were to have any number, you generally, have them be lower numbers. When you're talking about, a for loop or a counter variable, they're usually going to be relatively small. And so by doing this, we basically instantiate all of the integers at runtime, or, this small range of integers. We instantiate them at the very beginning of runtime, so that every time we go to use the integer wrapper class, we don't have to instantiate a new integer and use more memory. We already have the cache. So this cache is used within the integer class itself. The integer cache class itself is private, which means it's only accessible to integer, and then the cache array is the default visibility, so it's not private, public, or protected, therefore it's default. And so because the class itself is private, this means that it would essentially only be accessible to the integer class. And so there's no way that we could access it outside of the integer class, unless we use a trick. But just to show you really quickly, if we take a look at the constructor for integer, let's just see where it is. Actually, I'm not sure. See, it doesn't actually show it in here if you take a look. Public integer. So right here, when I say public integer int value, which is what I'm doing for z, then it simply just says this.value equals value. There's no reference to a cache at all, quite obviously, because I'm already instantiating it. But autoboxing, when Java does autoboxing, it will automatically call on that integer cache class that's hidden inside of the integer class itself. And so that's the difference between these two. When I directly instantiate it like this, I'm doing it myself, I'm skipping over the autoboxing. But when I have Java autobox the value for me, then it does rely on that cache. And so if I can change that cache, then therefore I can change the value. So this is a 1, but essentially what happens is it goes to the cache and asks for the integer, capital I, that corresponds with the number 1. And the code up here, I basically set each value equal to 1 more than itself. So instead of returning the integer that represents 1, it'll return the integer that represents 2. And so therefore when I go to print it and use it, it is equal to 2. Now, of course, if you just showed someone this code and asked them what was going on, they'd probably be very confused. Now, unfortunately, this doesn't work with just the primitive type, so you couldn't just drop this code into someone's project and not change anything and have it work. But if you change all the ints to integers, you could certainly fool your friends, and especially if they're using an array list, which uses integer, then you could fool them in that way as well. But without further ado, let's actually see how to do this. Now, in order to do this, we need to access and modify that cache field inside of integer cache, and that's not accessible to us normally. So we need to use a feature of Java called reflection. If you don't already know what reflection is, I have a pretty good video about reflection on this channel, so you definitely need to watch that first, because I'm going to assume that you already have a pretty good understanding of reflection. But essentially, we can use reflection to access things that we normally would not be able to because they might be marked as private, and we can also change things. So if a variable is marked as final, then we could change it. So for example, if you look at integer cache, the cache itself is marked as final, but using reflection we can override that and actually change it. And that's what all of this code up here does. I'm going to go ahead and create a new class, and we're going to write all of that code there from scratch. Okay, so let's go ahead and create the main method, and I'm going to copy over, whoops, that is the wrong class. I'm going to copy over x, y, and z just so I don't have to rewrite all of that, but we're going to do all of the actual code. So we're going to move step by step through this, because essentially what we're doing is we're starting out here in main and we're moving to integer, and we're just narrowing our scope until we're finally able to get and set the value of cache. So first of all, we need to gain access to the integer cache class. It's an inner class, so it's not defined in its own file. It's defined inside of integer. So we can do integer.class to get access to the integer class, and then we can do get declared classes. Now, unfortunately, there's no get declared class, and you can give it a name, so we're going to have to loop through all of these. This will basically give us an array of all of the classes that are declared inside of a given class. So basically all of the classes that are defined inside of integer in this case. I don't know if there are any other ones. I'm not really going to look for it right now, but at the very least that one is there. So we're going to put this inside of an enhanced for loop. We're going to say for class, because you can't use the word class. And notice I do class with the question mark in diamond brackets. That's the wildcard operator, or not operator, the wildcard for generics. Essentially, this is going to give us an array of classes, but we don't know the type of each class, so we can use a question mark for wildcard. So it is basically still generics, but we don't have to specify the type. Regardless, that's not terribly important. That's just why it's there. Now, we're looping through each class, and we need to find the correct class. So we need to say if class.get, we need get simple name. Don't use get name, because that'll give you the full package name and everything. We just basically want to do get simple name dot, and then we want to call, we want to say equals, whoops. Oh my goodness, I can't type. Equals, and integer cache is the name of the class. So if the class's simple name is equal to integer cache, then we'll just to show you, we'll say found it. And so if I run this code, you'll see that it does indeed say found it, which means that inside of this if statement, class is a reference to the integer cache class. We can access it directly. We couldn't do something like integer cache.class, for example, because we can't import integer cache because it's private and it's inside of integer. So even though, so I can do integer dot, and then, it would be integer cache, but that's not accessible to us. So we have to do it this way for the first part. Okay, so let's go back. Here's our integer cache right here. So now that we have the integer cache, we need to get access to this cache array. Notice that it's static, which means that we don't need to instantiate integer cache, so we can just go ahead and get it. So we'll go ahead and we need a field, so we'll call this cache field equals, and we need to do class.get declared field, and the name of the field is cache. So we're getting the field, and we're going to import java.lang.reflect.field. Make sure you import the right one. And, right, I forgot to put this inside of a try and catch, because a lot of the stuff that we're doing could result in various different exceptions. For example, trying to access something that doesn't exist, like a declared field that doesn't exist, trying to invoke something with the wrong arguments, or so on and so forth. But the point is that we're not going to raise any exceptions because we know exactly what we're doing and we're being very careful, but we do still need the try and catch. Okay, so at this point we have access to the cache field. Well, sort of. We can't quite get it because it's private. Or it's not private, but it's not accessible to us because it's default, and this is inside of a different package. So we'll first just go ahead and say we'll set accessible to be true. So therefore, it will be accessible to us, and we will be able to access it. Now we can go ahead and get the actual cache. So we can do cache field.get. And we can put null here because we're not invoking cache on an instance. We don't have an instance of integer cache, but we don't need one because the cache variable is static. So we can just put null there, and we do need to do a type cast to integer array. That's a safe typecast because we know that the type of cache is indeed an integer array. So at this point, we do have access to the cache. And if I go ahead and print, we can just take a look at it, arrays.toString cache, like that. And I run this, you'll see that it gives you all the values from -128, and we can scroll over up to 127. Remember, these are not actual ints, they are integers with a capital I. But essentially, you can see that this is an array that contains a bunch of values in it. So let's go ahead and let's play around with it. So we can say for int I equals 0, I is less than cache.length, I++, and then we can just say cache at index I equals cache at index I plus 1. So essentially what we're doing is we're setting cache at index I equal to whatever it was before plus 1, so we're shifting everything by 1. And if I go ahead, I'll go ahead and print it out one more time, arrays.toString cache, just like that. And you'll see it now starts at -127, and it goes up to 128, whereas it used to start at -128 and go up to 127. So you can see all of the values have indeed been shifted over by 1. So now that we've modified the cache, we need to set the value of the cache field because we got the value, but it doesn't bind to the actual field, so we need to update it. So we basically just need to do, we need to just call set. The instance is null because it's static again, and we're going to set it equal to cache. Whoops, pretty straightforward. So essentially we get the cache as it currently is, we then modify the cache, and then finally we update the field to reflect our new cache. Now if I go ahead and run this, we will actually get an exception. And this exception says, cannot set static final field to an integer array, essentially. So basically what this means is because the cache field is final, as we can see here, we can't just set it like this. And so that gives us an error and it doesn't work. Now, unfortunately, there's no cache field set final false or anything like that. It's actually a little bit more complicated than that. Basically, if we look inside of the field class, it has here an instance variable, private int modifiers. And modifiers represents all of the different modifiers of the field. So in this case, static and final are the modifiers. And since the modifiers of this field include final, it will not allow us to set the value. And we could actually take a look. Well, we don't really need to take a look, but the point is that when we go to try and call set, it checks the modifiers, and if the modifiers include final, then it will not work. Normally we would just give up here, but we can actually use reflection to help with our reflection. So we're actually going to do reflection on the field class and use that to modify the modifiers field and then make it work. That was probably really, really confusing, but let's just take a look at what I'm talking about. So we need to basically get the modifiers field for the cache. So we're going to do cache field.getClass. That's the same thing as doing field.class whatever. But we basically want to get the declared field called modifiers. So we're going into the field class and we're getting the declared field modifiers. Kind of funny that we're going into the field class and it's giving us back a field. But then we need to set the modifiers field to be accessible because it is indeed private, as we can see there. It's not final, of course, so we don't need to worry about that. Otherwise, we might be in trouble, but we're okay. Then we need to actually modify the field. And it's a little bit strange how it works. It's essentially a flag field, and there's a bunch of different values, and you use binary ands and ors and nots to make it work. And I'm not going to explain in this video exactly how like integer flags work, but I will show you how to do it and try to explain just a little bit how it works. But what we need to do is we need to take our modifiers field and we need to set the value. So we need to change the value of it. And what are we trying to change? We're trying to change cache field. We're trying to change the modifiers of cache field. And the new value is going to be basically we're going to call cache field dot get modifiers. So we're going to get the current modifiers of the cache field, and we're going to AND it with not modifier dot final, like that. And make sure you import the integer version. This should be an int value. So essentially what's happening is, based on this outer part, we're trying to modify the modifiers field. We're trying to change it for cache field, which is this right here. We're basically trying to change the modifiers of cache field so that they're not final anymore. And we're basically saying whatever the modifiers currently are, and we're ANDing it with the like not, or basically the opposite of final. And basically the important point of this is that this operation here will remove the final modifier from the cache field modifiers flag. So at this point, we've removed the final modifier from cache field, and so it is now able to be set. And if we run this, we get the output that we saw before. So just to do a quick recap, basically when, whoops, I zoomed out by accident. Basically, when you create a new integer and you use autoboxing, so when you make an integer capital I and you go like that with autoboxing, then it will use this hidden integer cache. And so if we can change the integer cache, then we can change the value of these integers here. And so to do that, we basically get access to the integer cache class. Then we get access to the cache within that class right here. That contains the actual values. We then basically set it accessible so that we can modify it. We set it to be not final so that we can change it. We then get the cache as it was before, modify the cache, and then we update the field with our new value. And so by doing this, it will change the integer cache, and so when it gets referenced automatically by the autoboxing, then it will actually give us a different value. Just to point out really quickly, if I change this +1 to be a -1, it'll actually say 129, which is a little bit strange, but essentially what's happening is the same exact issue here, because remember, cache is an array of capital I integers, and so when I try to set a value, this part here actually uses autoboxing. And so when I set it equal to value -1, then it basically has this effect where it changes one value, and then that has sort of a domino effect that it ends up changing all of the other values. And so if I actually wrap this inside of new integer and I run it, then it does exactly what you're expecting. Because basically what was happening was it was modifying the integer, but when we did +1, it would modify sort of, the one where it was before, and it wouldn't affect the ones in the future. When we changed it to be -1, it would affect the ones in the future, and so it would compound and you'd get something like -129. But by doing the new integer there, you're avoiding that fact. And then, for example, if you were to make this negative, then it does exactly what you're expecting. It sets it to be -1. But if you got rid of the integer and you just said negative cache, then it would just say 1. It would not keep the negative. That's just due to the fact that we're looping through this in order, and if we do the auto boxing, it's like accessing the cache while we're in the middle of changing the cache, and that can do some strange things. So by wrapping it in the integer constructor, we are explicitly avoiding the cache so that we can update it safely. Then over here, basically, it's the same thing as what we did here, saying new integer 2 instead of just 2, and this explicitly avoids the cache. So that's all for this video. As always, subscribe if you want to see more. Comment with what you want to learn. If you enjoyed this video, hit the like button, and I'll see you soon with some more videos. Bye for now.